Today we're going to be talking about if-then statements and conditional statements. And what a if-then statement is you have a hypothesis. If John lives in California, then from that hypothesis you have a conclusion. Then he lives on the West Coast. So if-then statements are also called conditional statements or conditionals, just three different words for the same thing. And P designates the hypothesis. So that is P, and this is Q. That's just a way that some mathematicians decide that they want to talk about the hypothesis versus the conclusion. It's just, instead of writing all that out, they would just talk about P and Q. And this comes into truth tables. I choose not to teach truth tables, but if you take some higher end math, you will be dealing with that. And P implies Q. That's what that little arrow means. So P therefore gives us Q, or P implies Q. Okay, so we have our original. If P, then Q. What the converse of a statement is. The converse is if you switch the hypothesis and the conclusion. So the conclusion then becomes part of the hypothesis part, and then the hypothesis then becomes the conclusion. So a converse. If you're in honors geometry at DLS, then you have Mrs. Marnell as a teacher. So then our converse, let's highlight our hypothesis. Our hypothesis is you are in honors geometry at DLS, and then our conclusion is then you have Mrs. Marnell as a teacher. And that is a true statement, because we are in honors geometry at DLS. And you guys have Mrs. Marnell as a teacher. But now our converse. You switch the blue and the red part. So if you have Mrs. Marnell as a teacher, then you are in honors geometry at DLS. Now think, this original was a true statement. Is the converse going to be always a true statement? It is not. In this case, it is false. Because you could be in Algebra 2, because I also teach Algebra 2. Okay? So, counterexample. An example that shows the conditional false. And that last one, being in Algebra 2, that's an example that shows the conditional false. A biconditional. A conditional in which the original and converse are both true. Okay, so if I had an example where both my original and converse were true, I can write that in if and only if form. Or an abbreviation for if and only if is IFF. I know how to spell the word if. That's an abbreviation for if and only if. Okay, state the hypothesis and conclusion. The hypothesis, I'm going to underline in red once, and the conclusion I'm going to underline twice in blue. So the hypothesis is the if part, the conclusion is the then part, but there are not always going to be an if-then form. So our first example, if Rick does not fail algebra, then he will not be eligible to play volleyball. Rick does not fail algebra. That is our hypothesis. And then our conclusion is then he will be eligible to play volleyball. So that is our conclusion. Two integers whose sum is 7 cannot be both even. Now this isn't in if and then form, but think of how you could put that in if then form. If two integers whose sum is 7, then they cannot both be even. So our hypothesis is two integers whose sum is 7. And our conclusion is cannot be both even. The next one, the game will be canceled in the event of rain. So if the game is canceled, then there was rain. Well, that's not necessarily true. But in the event, so if there is rain, then the game will be canceled. Okay, next example. Warren will sing provided Steve will play the piano. So, provided, fancy way of saying if, Steve will play the piano, then Warren will sing. So, if Steve plays the piano, then Warren will sing. Okay, writing each one of these in if-then form. So our if-then form. All dogs like to chase cats. So let's think of how I could write this in if-then form, and I'm going to type it out. So if you are a dog, then you like to chase cats. All cows eat grass, same thing. If you are a cow, then you like to eat grass. Okay, write the converse of each statement and state whether it is true or false. If it is true, write as a biconditional. If it is false, find a counterexample. So we're going to switch our given and our prove. Okay, so if tomorrow is Thursday, then today is Wednesday. And is that always true? Yes, that is. So now to write it as a biconditional. Today is Wednesday if and only if tomorrow is Thursday. Now the next one, our converse. If a polygon is a rectangle, make sure that your sentence makes sense. Notice how I didn't put if it is a rectangle. If a polygon is a rectangle, then it is a square. Now think, is that always going to be true? Or can we think of an example where that might not be true? Well, I'm going to draw a rectangle that's not a square. There's a really big rectangle where this is congruent to this, and that is congruent to that, and I have some right angles in there. That's a rectangle, but that's definitely not a square. Next example. Decide whether each statement is true or false. Provide a counterexample. So if x is less than 0, then x squared is greater than x. Well, okay, if x is, say, equal to 2. That works, because 4 is greater than 2. But now you have to be a little bit creative, and this is going to be the hard part for some of you. What if x was 1/2? X squared is 1/4. Is 1/4 greater than 1/2? This is false. And x equaling 1/2 is our counterexample. Two collinear rays intersect. Remember, collinear means lying on the same line. So I have a line. Now could I have two collinear rays that intersect? There's one ray that's on the line. There's another ray. Those are on the same line, but they do not intersect at all. So that's the hard part, is sometimes you're going to have to really think critically about your examples. There are your lesson questions for the day. You have 3 questions. Please make sure those are submitted on time.